In this video, we explore GitHub's powerful Sharding architecture, the secret sauce behind its massive scale and performance. GitHub's Sharding strategy is a sophisticated system designed to handle its massive and growing scale, millions of repositories, issues, pull requests, and users, while maintaining speed, reliability, and high availability. Let's dive deep into how GitHub shards its data and services. What is Sharding? Sharding is a type of database partitioning that separates large databases into smaller, faster, more easily managed pieces called shards. Each shard holds a portion of the data and is usually stored on a separate database server. Why GitHub needs Sharding? GitHub deals with billions of Git objects, commits, blobs, trees, etc., millions of users and repositories, high write/read throughput, global availability expectations. Traditional vertical scaling or single-node relational databases can't handle this scale. Thus, GitHub uses horizontal sharding to split and distribute data across different databases and infrastructure. GitHub's Sharding strategy overview. GitHub uses application-level sharding combined with MySQL database clusters, enabled by a system called Octoshard. Here's how it works. 1. Octoshard, GitHub's core sharding system. Octoshard is GitHub's custom-built system responsible for managing sharded MySQL databases. Each repository is assigned to a specific shard. Shards are MySQL clusters with red replicas. Routing logic is built into GitHub's application layer, Rails monolith, not the database. Key points. Shard assignments are consistent. All actions on a repo go to the same shard. Metadata, like which shard a repo is in, is stored centrally. Allows easy scaling by adding new shards and redistributing repositories. 2. Repository-based sharding. GitHub shards by repository ID. All data related to a repo, issues, PRs, comments, lives on the same database shard. Enables co-locating related data for efficient queries. Reduces cross-shard joins, which are complex and expensive. 3. Shard balancing. GitHub periodically rebalances shards. To avoid hotspots, some shards being overloaded. Uses background jobs to migrate repositories between shards. Ensures uniform load distribution across shards. 4. Isolation and fault tolerance. If a shard fails, only the repositories on that shard are impacted. GitHub has redundancy with red replicas and automated failover. Promotes resilience and containment of failures. 5. Git object storage, blob store, sharding. Apart from metadata in MySQL, actual Git data like commits, branches, tags, is stored in Git file storage backends like NFS or blob stores. These are also sharded and cached, often using content addressable storage, CAS, systems like Git LFS or internal S3 like systems. 6. Shard routing layer. GitHub uses service routing middleware to determine which database shard a request goes to, which backend services like CI, Git file servers should handle it. Ensures seamless developer experience even with sharded backend. 7. Operational tooling. Octoshard supports tools for monitoring shard health, shard migrations, query performance optimization, access patterns auditing. Benefits of GitHub's sharding strategy. Benefit. Description. Scalability. Easily add more shards to accommodate growth. Reliability. Isolates failures and limits blast radius. Performance. Queries are faster due to smaller shard sizes. Maintainability. Simpler to manage and back up smaller, isolated datasets. Challenges and trade-offs. Challenge. Explanation. Cross-shard queries. Hard to join data across shards. Requires workarounds or denormalization. Complex routing logic. Application needs to manage shard routing and failover logic. Data migration. Moving repositories between shards is complex and needs consistency guarantees. What's next? Future of GitHub's sharding. GitHub continues to evolve, exploring multi-region sharding, automating predictive shard balancing, using AI or ML to detect hotspots, enhancing observability and shard-aware dev tooling. Don't forget to like, subscribe, and hit the bell icon for more deep dives into real-world system designs and architectures.